I'm Anil Kumar, and here we have an excellent communication and thinking question on rate of change. Determine a function f of x with the average rate of change from x1 to x2 to be minus 4, the instantaneous rate of change at x2 to be minus 6, and f of x2 equals to 6. So let us see how to solve such a question. Now what we will do is we'll also develop an equation step by step. Let us assume that the function is quadratic. You could assume any particular function, but quadratic function is kind of simpler to work with. So I'm taking a very simple quadratic function f of x equals to x squared plus, let us say, some constant k. Now what is the instantaneous rate of change for a quadratic function? That is to say, if I have to have a slope at any point, it is how much? So we can actually do difference quotient and figure it out, right? So using difference quotient, we can find the slope of this at any point a. So we can use f of x plus h minus f of x over h, correct? Now that gives us x plus h whole square. We are replacing x with x plus h plus k, that is the first term, minus x square plus k divided by h, right? Now if you solve this, you get x square plus 2xh plus h square plus k minus x square plus k, right, over h. Simplifying, we know these two terms will cancel, right? And we also know that since h is very, very small as compared to 1, h square will be approaching 0, right? So this term approaches 0, right? So we'll consider that to be almost 0. What are we left with? We are left with 2xh over h, which is equals to 2 times x. So at any point on this parabola, instantaneous rate of change will be 2 times the x value, right? So this is what we now know from the calculations which we have done. I have very little space to do this question, so I'm kind of squeezing in. So this is what we have learned. What do we want to know? Instantaneous rate of change at x2 to be minus 6, right? So at some point x2, instantaneous rate should be minus 6. That means slope should be minus 6. So let us find that point x2. So we are saying that slope m at point x2 is equal to minus 6. Now slope is 2x. That means 2 times x2 equals to minus 6, and that gives us the point x2 as minus 6 divided by 2, which is minus 3. So we know that point x2 is minus 3 for our function f of x equals to x squared plus k. Now we also know that f of x2 should be equal to 6. That should help us to find the value of k. Now, so we'll do another part here. So that's kind of important. x2 is minus 3 for us, okay? Now, we have to say that f of x2, let me use a different thing. f of x2 is equal to 6. Now, function is x squared plus k. x2 is minus 3, we just found, right? So that means f of minus 3 is equal to 6. If I substitute minus 3 here, I get minus 3 squared plus k, right? Which is 6 equals to 9 plus k, or k equals to how much? 6 minus 9. That gives us k is equals to minus 3. So if k is minus 3, then we know what our function is. Isn't that interesting? Okay, so we'll go further. Here we are far from the answer, but we are very close. So k equals to minus 3. That means our function is how much? That means f of x is indeed equals to x squared minus 3. So that becomes our function, right? Now let's tackle the last part, which is determine the function f of x with average rate of change from x1 to x2 to be minus 4. We already know that instantaneous rate of change at x2 is minus 6 for the given function, and point x2 is minus 3, and the value is 6. So we have done the second half. The first part is we need to find point x1 so that the average rate of change is minus 4. How do we do that? So we have the function now, which is f of x equals to x squared minus 3. We basically need to find the point x1 so that the average rate of change is minus 4. That is to say, f of x1 minus, and x2 is minus 3 for us, right? F of minus 3 divided by x1 minus minus 3 is equal to minus 4. I hope you understand that part, right? Now let us write x1 here, so we get what? x1 squared minus 3, and f of minus 3 is known to us as 6, right? So minus 6 is equal to minus 4 times, we'll multiply by this term, which is x1 plus 3. Now we can solve for x1, right? Bringing it to the left, we get x1 squared plus 4 times x1 minus 3 minus 6 is minus 9, and minus 4 times 3 is minus 12. When it comes here, it becomes plus 12 equals to 0, right? So that gives us x1 squared plus 4x1, and here we have plus 3 equals to 0. So now I can factor this. So it is x1, 3 times 1, so it is plus 3 times x1 plus 1 equals to 0. Now this equation is true for x1 equals to minus 3 or minus 1. So we can take x1 as minus 1, right? So x1 equals to minus 1 gives us the solution, right? So we have found the point also between, so we have found a point x1 as minus 1. So now we have our equation, which is, let me conclude. So we have the function is f of x, which is x squared minus 3, x1 equals to minus 1, and x2 is equal to minus 3. This function with these 2 points satisfies all the conditions given in the question for us. I hope you understand and appreciate the steps we went through in solving such a question. Go through it once again, try to understand. This is indeed a very interesting question and sometimes a bonus question in test. I hope you appreciate it. Thank you and all the best.